So today, we're only going to be covering 2 sections out of Chapter 4, just because we've missed a couple class periods, and we need to make sure that we cover factoring, which is Chapter 5. So it's very, very important that we get as much covered as possible in Chapter 5. And I'm hoping that we can get through, in the next few weeks, all of Chapter 5. But Chapter 4 I've kind of cut down some of it because, of course, we've missed a couple class periods. So we need to make sure that we at least cover the bare minimums. So what we're going to be looking at first is we're going to be looking at, in Chapter 4, exponents. So we're going to be looking now at 4.1. And in Chapter 4, when we talk about exponents, exponents behave a little bit differently. And there are special rules for exponents that we have to use and apply. And exponents behave a little bit differently. When you multiply, exponents add. And when you divide, the exponents subtract. So we're going to go through these rules here. These are on page 285 at the bottom. So we're going to go through all of these rules. And this is on page 285. We're going to go through examples. We'll do an example with numbers. And we'll do an example with variables as well, just so you can kind of see how these work. Once we've got all the rules down, then we'll combine them together and learn how to simplify expressions. These are all expressions because there's no equal signs involved. All right, so no equal signs, so these are expressions. So we're not going to be solving for a variable. We're just going to be combining and working with like terms. So the first one that we're going to look at is the product rule. And these are all on page 285. And the first one, again, is the product rule. Now, for the product rule, when we multiply, the exponents add together. So I use the same variables as what they have for our definition. So a to the n, a to the m is a to the n plus m power. So what does that mean? That means when we multiply, the exponents are going to add together. So when we multiply, the exponents add together. So here's a few examples. P to the 5th, P to the 8th power. Now notice these are back to back. They have the same variable. They have to have the same variable or this doesn't work. These go together and make that P to the 5 plus 8 power, which adding them together is then P to the 13th power. So when we multiply, these exponents add together. Let's try another one. How about 3 times 3 to the 2nd power? Now, if there is a number or a variable with no exponent, then it's understood that there's actually a 1 there. Okay? So if there's no number for the exponent, you can put a 1 there. These have the same base. We're not going to multiply the 3's together because they have the same base, just like up here. These had a base of P, so that came out as a P over here. These have the same base, which is a base 3. There's no number for the exponent, so we have a 1. So that's 3 to the 1 plus 2 power, which is then 3 cubed. Now, how do we evaluate down 3 cubed? Well, what is 3 cubed? 3 cubed is 3 times 3 times 3, which is then 27. So that one would come out to be 27. If the power is small, like a 3 or a 4, then we evaluate it down. But if your power is something like an 8, a 9, or a 10 or larger, we will leave it alone, because then the numbers get too large. So if it's a small number, like 3 cubed, we can break that down. But if it would have been something like 5 to the 5th, or 5 to the 6th, we would leave it alone. So that is your product rule. So when we multiply, the exponents add together. Next, we have the quotient rule. Now, for the quotient rule, what do we know about multiplication and division? Well, multiplication and division are opposites, right? Okay. What about addition and subtraction? Those are opposites as well. So if we think about the product rule, when we multiplied, the exponents added. So the opposite of multiplication is division. And what's the opposite of addition? Subtraction. So for the quotient rule, what we do is we subtract. So if we have a to the n over a to the nth power, that's the same as a to the n minus m. So when we have our quotient rule, we're dividing and we subtract, because subtraction is the opposite of addition. So let's now look at a few examples of the quotient rule. So when we divide, we subtract. How about x to the 9th over x to the 4th? Well, we are dividing. So when we divide, what happens to the exponents? They subtract. Okay, just think of opposites. Exponents are a little bit different than numbers. So that gives me a common base of an x, and that's going to be 9 minus 4, which is then what? Which is then x to the 5th power. So when we divide, the exponents subtract. Let's look at another example. When we have a negative, we're still subtracting. And what happens with a negative times a negative? Well, that makes it a positive. So if we have, let's say, z to the 8th over z to the negative 4th power, what would that be? That would be z to the 8 minus, right, a minus 4. And what happens with a double negative? Well, that double negative is going to make it what now? Positive. Okay, so this here comes out to be a positive. What's my final answer then? 8 plus 4, that makes it a 12. So I would have a final answer of z to the what? 12 power. Works the same way with numbers. How about 8 to the 4th over 8 to the 2nd power? Well, students get confused because we're not going to divide these 8s, because these 8s are the base. So these have a common base of 8. And what's my exponents? 4 minus 2. And that gives you an 8 squared. And 8 squared is 8 times 8, which is 64. But where students make a mistake is they try to divide these out. These are the same. These have the same bases. So that means my base is an 8. We do not divide them out and get a 1. We'll use a common base of 8 here. So that is your quotient rule. Find another homework package here real quick. So now we look at the quotient and we look at the product rule. The next one is a little bit different too, because the next one is counterintuitive. The next one is a zero exponent rule. Okay, the zero exponent rule says any number to the 0 power is 1. So it doesn't matter what it is. If it's raised to the 0 power, it's 1. Variables, numbers, all the same. Here's some examples. P to the 0 power. Okay, P to the 0 power would be 1. 9 to the 0 power would be 1. It's not 0, it's 1. You can even have a grouping. So let's say x squared y z to the 5th, all raised to the 0 power. Well, what would that be? That would also be 1. Okay? Sometimes with the zero exponent rule, you've got to be careful as to what goes to 1 and what doesn't. So how about 8 x to the 0 power? Now, what do you notice about this one? When I look at this, are there parentheses involved? No. Okay? So, what's going to happen with that 8? Well, there's no number here, so we know that this 8 is actually 8 to the what? First power. So this right here, x to the 0 power, what is that? 1. So that would come out to be 8 times 1, which is then what? 8. Now, what is the difference between that one and this one? Now, this one on the left, this one came out to be 8, didn't it? Okay. What about this one on the right here? Well, this one has parentheses. So that means everything inside of there is being raised to the 0 power. And if it's all being raised to the 0 power, then that would come out to be 1. The entire part has a parentheses, so the entire part goes to 1. Do you see the differences here? Okay, this one, only the x was raised to the 0 power. So it went to 1, but the 8 stayed with it. This one is a little bit different, because this one has an entire grouping raised to the 0 power, so the entire part is 1. Let's look at one more of these. This goes back to the order of operations. So we're going to look at two of these. We're going to look at one of them again with parentheses and one of them without parentheses. Now, what do we know about any number to the 0 power? Any number to the 0 power is 1. There's no parentheses, so this negative comes along with it, and that makes that then a -1. Why is that? Well, if we think about order of operations, when we have this negative in front, that negative in front is multiplication. What's done before multiplication? Exponents and roots, right? So they're above that. So we do our exponent first, and this negative is like multiplication, so it comes along with it. Versus this one. Now this one, what do we know about this one? Well, this one is different with that negative because it's got parentheses. So this one, because of the parentheses, would come out to be 1. You have to be very, very careful with these exponents and look for things like parentheses because they look the same, but they're slightly different. Rules of exponents are easy to do as long as you're careful. And a lot of times here, what happens is students aren't careful and you make a slight mistake like one of these. These are different. And so these are examples of the zero exponent rule. So we looked at the zero exponent rule. The next one is the negative exponent rule. Now for the negative exponent rule, whenever we have a negative exponent, we can express that as a fraction. So that's our negative exponent rule. When we go to actually work out questions, a lot of times in the directions, it will tell you at the end, write your answer with only positive exponents. So we need to make sure that we know how the negative exponents work. So we're going to look at some examples of negative exponents. We'll do a real easy one first. X to the negative fourth power. So x to the negative fourth power. We never want negative exponents in your answer. So that would be rewritten as 1 over x to the fourth. So always rewrite your negative exponents as a fraction. How about 9 to the negative second power? Well, this one would be written as 1 over 9 squared. And we know that 9 squared is what? 9 squared is 81. Again, we have to be careful as to what has parentheses and what does not. So I'm going to give you, again, 2 examples that are slightly different and give you different results. So how about 5x to the negative third power? In this case, we do not have parentheses. So the 5 stays on the top. No parentheses, so that stays on the top. What about down below? Well, down below would be x what? Yep, x cubed it. Let's look at it with parentheses around it. If I put parentheses around it, what would that mean? What would that look like? Well, in this case, the entire part goes down to the bottom. And that would be 5x cubed down below. And this is going to kind of talk a little bit about what we're going to be using next, which is the power rule. Okay, so that entire part goes down below. And this is building on the power rule. We'll talk about the power rule specifically next. But we're just going to kind of do a preview of that because we've got these parentheses and we can distribute it through. And that gives you then 1 over 5 cubed x cubed. And what do we know about 5 cubed? That's 5 times 5 times 5, and that comes out to be 125. So this would come out to be a slightly different answer than the previous one, and it's going to come out to be 1 over 125 x cubed. Do we see the difference there? And this again is starting to build up to the power rule. Power rule says we can distribute things through. So now let's move on and let's look at our power rule. And there's lots of examples of the power rule. Power rule just means you distribute things through. So the power rule says, we'll do the first one. A to the m to the nth power is a to the m times nth power. So that means when we distribute through, the exponents multiply because of the parentheses. Think about distributing with parentheses. If there's a 5 in front, what do? You distribute it through. Okay, same process here. So x to the 8th quantity squared, what would that be? Well, that would be x to the 8 times 2 power, which is then x to the 16th, because they multiply. When you have parentheses, the exponents are going to multiply. Same thing with numbers. How about 5 to the 4th, all raised to the 8th power? And that would be 5 to the 4 times 8. And that makes it then 5 to the 32nd power. Now, if it's going to be a large exponent, like more than 4 or 5, you don't need to break it down. 5 to the 32nd power, well, what would that be? That would be 32 5s multiplied together. And that would be a huge, huge number, so you can leave it like this. If that exponent is much above 4 or 5, you can leave it as it is. This is too large for us to work out. If I wrote it out, I would have to write out 32 5s in a row, multiply them together, and I would get a huge number. And it's just not feasible to write it down. So we'll leave it as an exponent. So anything that's above about a 4 or a 5 power, we just leave it as it is. Now another part of the power rule says that we can distribute powers through parentheses. So AB, make sure, yep, and they don't put any exponents on, just using the same variables and powers that they use. AB to the mth power is a to the mth power, b to the mth power. Because what we did is we distributed it through. So it's just like multiplication and parentheses before. So let's look at a couple of examples of this one. How about 4x to the 9th power, all squared? Well, what are we going to do? we've got parentheses. So think about parentheses before. We're going to distribute them through. That comes out to be 4 squared x to the 18th power. Now, where do students make a mistake? I guarantee that someone is not going to write out 4 squared. They're going to write out 8, and that is not correct. You have to distribute your square through, and then what do we know about 4 squared? 4 squared is not 8. 4 squared is what? 16. So what would your final answer be? 16 x to the 8th power, not 8 x to the 18th. It's going to be 16. Do we see the difference there? Okay, so we're not multiplying the numbers, we're using it as an exponent. Let's try another one of these. This one's going to have multiple variables using the same process though. How about we look at x to the 8th, y to the 5th, z to the 4th, and we'll do a negative exponent as well. How about p to the negative 5th power, all cubed? This one looks complicated, but it is really not. I did put in a negative exponent to kind of bring back that negative exponent rule. So what do we need to do? Well, we need to go ahead now and distribute that 3 through. So when we have parentheses, those exponents multiply. And what does that give you? Well, that gives you an x to the 8 times 3 power. And 8 times 3 is a 24. Then we've got y, and we've got 5 times 3. 5 times 3 is a 15. And we have a z to the 4th power. 4 times 3 is a 12. And then we have p to the negative 5th, and negative 5 times 3, that's p to the negative 15th power. When we write our answers, we never ever want negative exponents. So this negative exponent here on this one is going to make it go down below. So this is going to make it a fraction. So whenever you have a negative exponent, you rewrite it as a fraction. So we've got x to the 24th, that stays on top. Y to the 15th power, that stays on top. Z to the 12th power, that stays on top. But what about that p to the negative 15th power? Well, it has a negative exponent, so that would come down as p to the 15th power. And it'll be positive when it comes down. And this is your final answer right here. So whenever we write our answers, we want to make sure that we do not have any negative exponents. Very, very important. Only positive exponents for your answer. Now I'm going to work with negative numbers raised to powers, just so we understand how these work. And once we're done looking at these, then we'll put everything that we've learned so far together. So negative numbers raised to a power. So negative 4 with parentheses, quantity squared. Do we think that's going to be a positive 16 or a negative 16? Well, we need to write it out. Now, what do we have? We have negative 4 inside parentheses, and it's squared. So that's going to be negative 4 times negative 4, and a negative times a negative makes it a positive 16. What about a negative 3 to the third power? Well, a negative 3 to the third power would be then negative 3 times negative 3 times negative 3, and 3 negatives are going to make this one then a what? Make this one then a negative 27. So we have to be very careful with these powers, and let's look at one more. What about negative 2 to the fifth power? That's going to be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. You can use a calculator. I'm going to work this one out by hand just so you see. Do you think it's going to come out to be a positive number or a negative number? Negative. Okay, why? Yep, because there's 5 of them, right? And if we break it up into pairs, what do we have? Negative 2 and negative 2, well, that makes it a positive 4. Negative 2 and negative 2 also makes that a positive 4. And then still a negative 2 on the end. And when we multiply all those together, we have 16 times a negative 2. And that would make that then what? That would make that a negative 32. Now let's look at our answers here. Negative 4 squared. That came out to be positive 16. 2 is an even number. Negative 3 cubed. 3 is an odd number, and it came out to be negative. Negative 2 to the fifth power. Odd number, and it came out to be a negative 32. So we're now going to look at a general rule for these. So a negative number raised to an even power is going to come out to be positive. A negative number raised to an odd power comes out to be negative. Let's just look at one of these. We're going to do it first by writing it out, and then we'll use our rule to justify it as well. Let's look at negative 1 to the fourth power. That's negative 1, negative 1, negative 1, and negative 1. So it would come out to be positive, right? And what do you notice now about 4? 4 is an even number, isn't it? Okay, so since that was an even number, it came out to be positive. So whenever we work with negative numbers, we can either write it out like we did here, or we can use our rules and look at whether it's an even or odd. Now let's combine everything that we've learned so far together. So this is going to kind of put all of the rules that we've learned all together. And we're going to try and simplify. So let's try to simplify this expression. So this is a pretty easy one, but this makes us use several concepts together here. This is actually going to use two of the concepts. Well, first thing we look at is we look at the fact that we've got parentheses. So we're going to go ahead now and just distribute that 2 through. And there's different ways of working these out. I'm just going to begin by distributing that 2 through. So when I distribute that 2 through, that leaves me then with 5 squared. Commonly made mistake is someone's got to write down 10. It's not 10, is it? It's 5 squared because that squared goes through. Because again, remember, if there is no number, what do we know the exponent is? The exponent is a 1. And 1 times 2 is a 2. Then we have x to the 4 times 2 power, which is, 2 times 2 power, which is an x to the 4th. What about the z? 2 times 0 is still 0, and we'll deal with that in a moment. Down below, we have 3 what? 3 squared when we distribute 3. So we just applied our power rule. Now we're going to clean this up a bit. 5 squared is 25. X to the 4th stays as it is. But what about this z to the 0 power? What do we know about any number raised to the 0 power? What is that? 1. So it's gone. Because any number raised to the 0 power is 1. What about down below? 3 squared is 9. Do we have any negative exponents? No. So we're done. And that's going to be our final answer on that one. So we simplified it down by using our power rule, and we also used our 0 exponent rule.
So it becomes a 1, you just don't use it.
Yeah, because 1 times anything is just itself, right? So it's basically gone. It's not 0, because 0 would make the whole thing 0, right? It's 1. Any number raised to the 0 power is 1. So it just goes away. Okay, let's try another one here. So we're going to try and simplify another one of these down. And let's say we look at it cubed. All right, now this is where there's two ways of working this one out. You could go ahead and distribute that 3 through at the very beginning. But I think it's going to be easier and less confusing if we work with our order of operations. Now, order of operations, what do we do first? Parentheses, right? So we need to break down these parentheses. Then we'll distribute that 3 through. You could do it right now, but it's going to be more confusing than if we simplify it first. So we're going to do our parentheses first. So over to the side is going to be our work. And let's see what we've got. We've got 8x to the 5th, z cubed, over 4 x to the negative third z to the ninth. We're going to break it down in individual parts. So then we'll break it down, and then we'll put it all back together. So let's first look at 8 over 4. Well, 8 over 4, what does 8 over 4 reduce down into? 2. So that's gone. Okay, so we just did their numbers. 8 divided by 4 is 2. What about the x part? What about x to the fifth over x to the negative third? That's going to make us apply our quotient rule. And so when we divide, what happens with our exponents? When we go to divide these subtract, and watch out for double negatives. So that gives me x to the 5 minus a minus 3. And what do we know about the double negative here? Makes that positive. So the x part comes out to be x to the what? 8th. Okay, so there's that piece. What about the z's? Similar. We have a z cubed over z to the ninth power. That is then z to the 3 minus 9, which is then z to the what? Negative 6th. So what does all of this now come out to be on this side? Put it all together. We are left then with the 2 x to the 8th z to the negative 6th power. Now you could go ahead and get rid of that z to the negative 6th power now and make it a fraction. I usually do not do that. What I usually do is get rid of the negative exponents that very last step. So I usually save it until the very end. So we broke down everything inside of the parentheses there, one piece at a time. Now what can we do? Now we can go ahead and distribute that 3 through. And when we distribute that 3 through, we're using our power rule. So that means then that the exponents multiply. So what do we have now? We have 2 cubed x. How many of those do we have? Well, 8 times 3. 8 times 3 makes it then a 24. Negative 6 times 3, that makes it a z to the negative 18th power. We need to clean this up a little bit. What can we do with this z to the negative 18th power? Well, it's a negative, so where does it go? It goes down below. So what's our final answer look like now? 2 cubed is 8. X to the 24th stays on top. And then what goes down below? Z to the 18th power, right? So it goes down below. So that would be now our final answer here. These are not really difficult. It's just that there's rules, and we have to make sure that we understand the rules. And sometimes the rules are counterintuitive. When we multiply, we add. When we divide, we subtract. Parentheses, we distribute through. So they are a little bit different. But once you understand the rules, it's not that difficult. Let's try a couple more of these, and then we'll take a short break. So let's try now about a negative 4 x to the 5th z to the negative 3rd all raised to the negative second power. And again, we're going to be trying to simplify it. When I first look at this, can I combine anything together inside? No, because we've got a 4, nothing can go with that. We have an x and a z, so those can't go together. So there's nothing to break down on the inside. What we can now do is we can distribute this negative 2 through. When we have a negative number, we need to make sure that we put parentheses around it. So when I distribute that through, because there's parentheses, that's going to be negative 4 to the negative second power. Negative 2 times 5, that makes it an x to the negative 10th power. What about the z, though? Negative and negative here makes it a positive z to the 6th. Whenever you have negatives, you need to make sure when that number is negative that you put parentheses around it. Now we can go ahead and move everything down and work with it. So what do we know that's going to stay on the top? What about all of this? What's going to happen with all of this? Well, all of this has a negative exponent, so it goes down below. So what stays on the top? Z to the 6th. The z to the 6th is positive, so it stays on the top. What's going to go down below? Well, what is down below? We have a negative 4 squared, because the exponents change when they come down. Z to the 10th. We've got one more step here. What about that negative 4 squared? Do you think that's going to be a positive 16 or a negative 16? Which one? Positive. Why? Because you've got the parentheses, and that 2 is an even number. So that would come out then as a 16x to the 10th. How do we know we're done? Because a lot of times students try to make it more difficult and don't know when to stop. When do I know I'm done? Well, I know that I'm done because I can't break it down. The z's and the x's cannot go together. We have no negative exponents, so we know we're done. So you have to make sure you have no negative exponents in your answer, and nothing can be combined together. So let's look at one more of these, and I'm just going to pick one from our textbook here. So if you don't have your textbook or don't want to get it out, that's fine, because I'll write it up on the overhead here. Let's look at, how about we look at question 141. And this is going to be on page 289. So we're going to look at question 141. We'll take a break after this one, but we're really going to take our time when we work this one out, because this one can be tricky. We have to watch our steps and make sure that we use our order of operations correctly. So we have 2p over q squared, all raised to the 3rd power. And then we have 3p to the 4th over q to the negative 4th power, all raised to the negative 1st power. So we're going to work this one out very, very slowly, and we're going to make sure that we know how it is done. So we're going to do it piece by piece. Order of operations. Again, this all goes back to order of operations. Before I multiply these together, what's first? Remember, order of operations, exponents are above multiplication, right? So we do the exponents, then we multiply and put everything together. So let's do our exponents first. And we're going to do each one on the right-hand side and then plug everything back together. So we now have 2p over q squared, all raised to the third power. Let's break this one up first. So what do? Distribute that 3 through. Because the p and the q can't go together because they're unlike. They're not like terms, they're unlike. So let's go ahead and distribute this through. That's going to be 2 cubed p cubed over 3 times 2 makes it a q to the 6th power. And we know 2 cubed is small enough that we can work with it. So that would be 8 p cubed over q to the 6th power. So there's that piece. Now we're going to do the next one. The next one is 3 p to the 4th over q to the negative 4th power, all raised to the negative 1st power. Whenever you have a negative 1, that's simply flipping over the fraction. So you can just flip it over. I think that that's one more thing to try to remember. So we're just going to distribute that negative 1 through. But whenever you have a negative 1 power, you could simply just invert that fraction. But I'm going to go ahead and just distribute it through and move things around this way. Because I don't really like to teach us one special case rules in this class, because I want us to understand the concepts. Now in college algebra, you could use that special rule. You could flip it over with a negative 1. But we're just going to go ahead and distribute it through. So that's 3 to the negative 1st, p to the negative 4th, over q. Now what's going to happen here? Negative and negative makes it then a what? Positive. I'm going to go ahead, and you can get rid of the negative exponents whenever you want. I'm going to go ahead and get rid of them now. You could wait and get rid of them later, but I'm going to go ahead and choose to get rid of them now. So what's going to happen here? Well, all of this has negative exponents. So where does that make it go now? Yep, it goes below. If it's all gone in the numerator, we leave a 1. So when I distribute that through, all of it's going to be gone, and we have a 1. Now what's down below? 3. We've got a p to the 4th and a q to the 4th, because everything else is gone on top, so we leave that 1. All right, that 1 just stays there. Now we can finish up our problem. So there's that piece, and we're almost done. We're going to go ahead and multiply across and just see what we've got, and we'll combine things together. So let's go ahead and just multiply the numerators together. 8 times 1 here. 8 times 1 is an 8. So that's 8p cubed on the top. What do we have down below? And I'm just going to write it with the number, the coefficient first. So the 3, that's our only number. I'm going to write that first. And then we have a p to the 4th. And then we have a q to the 6th and a q to the 4th. Because those can go together. Once you get good at these, you can skip a lot of steps. Right now I'm showing you every single step so there's no confusion. But once you get good at these, you can just skip a whole bunch of steps at once. But I'm not doing that. I'm making sure that we see every single step. Let's look at what I've got circled here. And again, there's different ways of approaching it. You can do the quotient rule first. You can do the product rule first. But eventually, everything's got to be combined together. What do we know about the q's down below? These have the same base. They're both below. Are there any parentheses around these? No. So are the exponents going to multiply, do you think, or add together? Which one? Multiply or add? Well, when do we multiply? We multiply when we have parentheses. Do we have parentheses around these at all? No. So that means we're going to apply our product rule. And what does the product rule say? When we multiply, the exponents do what? Add together. So that gives me now q to the 10th power. So the only time that we multiply these exponents is when we have parentheses. And we don't have them here, so we're going to go ahead and just add them together. Now what about the p's? And again, if you want to, you can just write it over here if you want to use some scratch paper. What about the p's? We have a p cubed over p to the 4th. What are we doing when we look at just the p's? We're only going to do it one piece at a time. Yep, we're going to subtract them. And that leaves you then with p to the 3 minus 4 power, which is then p to the what? Negative first. So now let's see what we've got. We've got one more step left here. So we've got an 8 p to the negative first over 3 q to the 10th. Almost done, but what's the very last thing we need to do? We need to make sure we do not have any negative exponents. So this p to the negative first, where does it need to go? Down below. So our final finished answer is 8 over 3 p q to the 10th power. And I know there's a lot of steps, but they're very simple steps. It's just adding, subtracting, and multiplying. So let's take a short break, then we'll come back. We'll look at some more of these, and then we'll look at 4, which is multiplying these polynomials. So let's take about a 10-minute break, and let's meet back now at 9, how about 45? So meet back here about 9:45.